Hey there, 8th graders, and welcome to today's Explainer. I'm absolutely thrilled to be your guide as we embark on a brand new mathematical journey together. Today, we're exploring infinite horizons, mastering the volume of spheres. So grab your notebooks, your pencils, and definitely your sharpest thinking caps, because we are going to unlock the secrets behind one of the most fascinating shapes in the universe. I promise you, by the end of our time together, you're going to look at the world around you in a completely different way. Okay, let's dive into this. Here's the roadmap for our learning adventure today. We're going to hit the perfection of spheres, why sphere volume matters, the formula unlocked, solving real-world examples, your homework challenge, and we'll wrap it all up with education with biblical morality. Let's kick things off with Section 1, the perfection of spheres, taking a look at divine design and geometry. You know, when you really stop and think about it, a perfectly round sphere is literally a marvel. There are no harsh angles, no sharp corners, just a continuous, perfectly symmetric curve that's the exact same distance from the center at every single point. It's a shape that has totally captivated thinkers, scientists, and mathematicians for thousands of years. And this mathematical perfection, it didn't just happen by accident. As Proverbs 3:19 reminds us, by wisdom the Lord laid the earth's foundations, by understanding he set the heavens in place. When we study the exact flawless geometry of a sphere, we're quite literally studying the foundations of the universe. From the shape of the earth we're standing on to the stars set in the heavens, this perfect roundness is a foundational building block of creation itself. Now, what's really interesting about this slide is how it contrasts the spheres we're focusing on today with the 3D shapes you've already mastered. Think about a cylinder, like a standard soup can. It has flat surfaces on the top and bottom, and calculating its volume relies heavily on its height. But spheres, they are perfectly round 3D objects. There are absolutely no flat faces or edges anywhere. Because they lack height in the traditional sense, their entire volume calculation relies entirely on one single measurement. Just one, and that is the radius. Moving right along to Section 2, why sphere volume matters. From bubbles all the way to aerospace. Because, let's be real, this isn't just stuff that lives in a textbook, right? This is geometry in action. Spheres show up in real life way more often than you might think. Think about the basketballs you shoot on the court, those delicate soap bubbles floating in the air, the massive planets orbiting the sun, or even just tiny water droplets. Understanding how to calculate the space these curved shapes occupy actually helps us solve massive, real-world problems. If you're dreaming of an exciting career in science, sports design, or aerospace engineering, knowing how to calculate the volume of a curved shape is an absolute must. You're literally learning the math today that could help you design the next generation of spacecraft tomorrow. How cool is that? All right, Section 3, the formula unlocked. Time to crack the math code. Now, if you've ever felt intimidated by complex math formulas, I want you to just take a deep breath. I'm right here with you, and I promise you, you already have all the skills you need to totally master this. Here is the golden key to our lesson. The volume of a sphere is V equals 4/3 times pi times the radius cubed. So the crucial point is that because a sphere is perfectly round, with absolutely no flat faces, measuring its size is all about finding out exactly how much space it occupies on the inside. And all that internal space is determined simply by taking that center-to-edge measurement, the radius, and running it through this formula. Let's break that formula down so it's incredibly easy to use. It's really just 3 foolproof steps. Step 1, cube the radius. That simply means you take the radius and multiply it by itself 3 times. Radius times radius times radius. Step 2, multiply that result by pi, which we typically just estimate as 3.14. Step 3, multiply that new number by the fraction 4/3. And honestly, that's it. Just 3 simple actions to unlock the volume of literally any sphere in the universe. Let's move to Section 4 and see how this builds. Solving real-world examples. Let's do the math. Okay, it's time to take all this theory and put it into practice. Here's our first scenario. Imagine you're holding a standard basketball. It has a radius of 4.5 inches. So from the very center of the ball straight to the outer leather edge, it's exactly 4.5 inches. What is the total volume of air inside that basketball? Let's follow our 3 trusty steps. Step 1, cube the radius. 4.5 times 4.5 times 4.5 gives us 91.13. Step 2, multiply by pi. We take 91.13 and multiply it by 3.14, giving us approximately 286.15. Step 3, multiply by 4/3. So 4/3 times 286.15 brings us to our final answer, approximately 381.53 cubic inches. Look at that! You just calculated the volume of a basketball perfectly. See? Not so bad. Let's try another one, but hey, pay super close attention here, because there's a classic math trick hiding in this question. A classroom globe has a diameter of 14 inches. What's the volume? Did you catch the word that changed? I didn't say radius, I said diameter. Yep, you guessed it. Before we can use our amazing formula, we have to find the radius. The diameter is the distance all the way across the sphere, but our formula only wants the distance from the center to the edge. So we divide that 14-inch diameter right in half, which gives us a radius of 7. Always check to see if a problem gives you the radius or the diameter first. Now that we have our radius of 7, the math is an absolute breeze thanks to our scaffolding. Step 1, cube the radius. 7 cubed is 343. Step 2, multiply by pi. 343 times pi gives us approximately 1078.1. Step 3, multiply by 4/3. 4/3 times 1078.1 gives us a final estimated volume of 1437.47 cubic inches. You guys are doing fantastic with this. Let's do one final practice problem, but on a much smaller scale. Estimate the volume of a ping pong ball with a radius of just 2 centimeters. And this brilliantly illustrates the real beauty of mathematics. The exact same rule that applies to a massive planet applies perfectly to a tiny little ping pong ball. Step 1, cube the radius. 2 times 2 times 2 is 8. Step 2, multiply by pi. 8 times 3.14 is 25.12. Step 3, multiply by 4/3. 4/3 times 25.12 gives us an estimated volume of 33.49 cubic centimeters. Whether it's inches or centimeters, big or small, the formula never fails us. Which brings us to Section 5, your homework challenge. Time to test your skills. You have fully unlocked the formula, and it's time to test your skills independently. You now have every single tool you need in your mathematical toolkit to conquer these next problems. Here are your 5 challenges. First, find the volume with a radius of 6 centimeters. Second, find the volume with a diameter of 10 centimeters, and watch out for that trick. Third, a snow globe with a 5-inch radius. Fourth, a beach ball with an 18-inch diameter. And fifth, a real brain teaser for you. If a sphere has a volume of 904.32 cubic centimeters, can you work backward to find the radius? I want you to go ahead and pause this explainer right now and copy these 5 problems down into your notebook. Finally, Section 6, Education with Biblical Morality, Wisdom Beyond Math. Welcome back. So, we've tackled some incredible mathematical wisdom today, but at HeroesMart Academy, we believe there's a wisdom that goes far beyond math. As a teacher, I care immensely about your ability to calculate the volume of a sphere, but honestly, I care even more about the person you are becoming. Our Godly Learners series intertwines biblical morality with education because, truthfully, education without morality will hurt. I mean, what is the point of being brilliant, of having all this mathematical knowledge, if you continue to make choices that hurt yourself or hurt the people around you? Character matters just as much as intellect. When we combine our intellectual pursuits with a really strong spiritual foundation, something beautiful happens. Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. That is the exact experience we want for you as you engage with our content. We don't just want you to be smart. We want you to have profound, lasting peace of mind as you navigate this big world. So, I want to leave you with this final kind of provocative question as you close the explainer and start that homework. How will you apply both your new mathematical knowledge and your moral compass today? Use your smarts to solve the problems, for sure, but use your character to be a light in the world. Good luck with those calculations, 8th graders, and I absolutely cannot wait to explore more infinite horizons with you next time.